next one. Can you believe that these two squares are the exact same size? Well, can you? You know why you can't believe that they're the same size? Because they're not. They're not the same size. Can you believe that they put that in the book? That's it. Alright. Alright, next. Arc length formula. I didn't put that down when I derived this in the last video, but I want to make sure you're understanding it. When you have to find the arc length, if it's a curve, you use this. Keep in mind, if it's not a curve, if it's a straight line, use a diagonal line, use the Pythagorean theorem. If it's a horizontal line or a vertical line, you use those methods that I taught you. Right, top, bigger number minus the smaller number, top minus the bottom, right minus the left. However you think of it, do as little work as you need to on these problems to save yourself some time on the parts that take more time. So when you have to find the perimeter of a region, just make sure that if it's straight line segment that you're using either the Pythagorean theorem or the other methods. You don't always have to use arc length, in other words. Okay, so enough said there. This is the arc length formula when we are finding the length of an arc where y is a function of x, y is defined as a function of x. And I wanted to point out that this same derivation works when x is a function of y. So just in case you have to find the length of an arc in which the arc is determined or defined in terms of y, x as a function of y, we're going to integrate from c to d, okay, c to d, and the length of one line segment, again, same thing. We start here, but then, let's see, how can I show all of this to you? We get to, we'll get back to this part here. S equals the square root of x squared plus, dx squared plus dy squared. So I'll just derive that here, and understanding, so the same thing that we had in the last problem, where we have x instead of y equals f of x, we have x equals f of y, and therefore when we square both sides, we take the derivative of both sides and square it, we get f prime of y squared dy squared. So dx equals f prime of y dy, squaring both sides we get that, and then the formula becomes almost identical to the other one, square root of, same kind of thing, dx squared, we're going to substitute in our f prime of y squared, dy squared plus dy squared, and then a few steps later we can see we would factor out the dy squared, we would separate the square roots, and so we would get f prime of y squared plus 1, and then multiplied by the square root of dy squared, which is just dy. But the preferred way to write that would be 1 plus f prime of y squared. And again, just like in the area of a face of a disk, pi r squared, don't forget the pi. Remember the pi, remember the squared. In this case, remember the squared there. That's the one where students always forget. So the two arc length formulas would be, they're virtually the same. It's just to replace the x with the y if you're integrating with respect to y. But let me go ahead and write them down right on top of one another. Over here, a to b in the x direction, and we're consistent with this, guys. C to d in the y direction. So that would be another thing to remember. You're integrating from c to d, and that would be 1 plus f prime of y squared dy. Okay, so these are the two arc length formulas, depending on in which direction you're planning on finding the length of the curve, which direction or how the function is defined. X is a function of y is a function of x. So in the next video, we're actually going to start doing some problems, and that's the easy part, as long as you remember the key parts of these formulas. See you in the next video.